Okay, so now that you've got the board assembled, we're about 90% there. What we have to do now is add in the reworks, and this is for the main actual trigger mechanism for this board to wake up on a normally closed input. And we'll talk about that too, but the components that are involved here are the P-channel MOSFET Q2, a 100 k ohm resistor, and a 10 microfarad capacitor, electrolytic. And the first thing we need to do to this board is actually cut a trace. So with a sharp tool like an X-Acto knife or a blade of some kind, we need to cut a trace. And this trace is going to be right there. Okay, so what we can do though, just to make sure that we do it correctly, is grab your meter and set it up to measure resistance or continuity if you've got it. And this point right here connects up to the gate of Q2, the center pin, and you can hear that we have continuity. Okay, and we want to make sure that we also do not short this out to this top plane here, which is connected to ground. Okay, so we can test that easily by going up to ground right here. Okay, hopefully I'm not covering everything up. So, because sometimes when you cut a trace, you will accidentally actually short the trace to whatever the fill plane is on top. So we'll go ahead and do that now, and I'll show you how to test for it. So I'm going to cut this trace first. Okay. And let's see how I did. Might have to go at it a little bit harder. Oh no, I'm good. Okay, so testing again from this point to the gate. I now have an open circuit. I'm going to test that to ground just to be sure. Test it from there to there, and then I'm also going to test it again from there to ground. Because you can see that, see I'm touching the copper over here. You can see that it'd be pretty easy for some of the copper there as I'm cutting it to actually short to ground. So just double checking that, and we are good. Okay. So now that we have the trace cut, what we need to do, and this is one error in the design, is that Q2 is actually put in that footprint there. You see we're showing the flat side going down is backwards. So Q2 actually goes in with the flat side up like that. Okay? And we'll just go ahead and do that. Now when I solder Q2, I'm going to solder the, my soldering iron timed out there. That's a good thing. My bench timer circuit's actually working. So what I'm going to do though is solder the source and drain of Q2, but I'm going to leave the, I'm going to solder the gate to the center pin, but I'm going to not cut that because we're going to use that to solder other stuff to here. Okay. There we go. And then we'll just trim the source and drain leads. Okay, so you should look like that. All right, now this isn't going to be pretty, but like I said, this is a an experimental board. But what we're going to do is change the pull-up resistor on Q2 to a 100K. Originally, I had a 10K in, but that was a little too strong of a pull-up for what we're doing here. So I'm going to have to actually do it like this. It's not pretty, I know. But I'm thinking, this is the first time I'm doing this, by the way. So if we kind of do, if I lay that in there, and maybe like that. I just don't want that, the lead to short to anything else. But what we're trying to do is basically connect that 100 k ohm from this point here to the gate of Q2. So anyway, I'm just gonna kind of go for it here. So I'm thinking like that, maybe around like that a little bit. So like something like that, that should work. I'll just solder those together. Yeah, that'll work. I mean, it's not pretty, and I might even put some hot glue on it so that it doesn't move around and short out. You just don't want the leads of this 100K touching any of these through hole points here, and especially not right there. I'm losing light here. Okay, that's better. Okay, now the next thing before I cut anything, we need to add this 10 microfarad capacitor. Now this goes from this point here now, the other side of R8, to that same gate point. Okay, so basically what we're doing here is with the, let me just double check it here, yeah. So with the negative part, or the negative lead of the capacitor will go up here. You know, we want it to go to that other side of R8, and then the positive side of the capacitor goes to that same gate point. Now, let me see if there's an easier way to do this. I don't think so. I'd hate to have this large component on the bottom, but I mean, unless I did it like that and then wrapped it around, but I think that's going to be a little too, that might be a little tricky. Yeah, I'll just put it on the bottom. And then in the next revision of this board, I'll fix this up. It's like, yeah, maybe if we just, ooh, that's, oh man, that's not good looking. But that might work. Like that. Yeah. All right, let's try that out. Just solder all that stuff together. Okay. So basically what the reasoning for this was that the supervisor chip, the way this works is I'm monitoring this normally closed input right here to in. Okay, so you'll have your sensor here hooked up, your door sensor to the positive through hole here and the input through hole. Okay, and when it sees this voltage go away, the supervisor chip is monitoring that. So it doesn't need an input or any kind of strap on it, no pull up resistor, pull down. And the supervisor chip, as soon as it sees that input go away, that voltage go away, it will yank its output low. Now my plan was, hopefully, originally when I was designing this, was that input would pull low and then tri-state, but it does not. So it doesn't go into that high impedance state. It continues to pull low, and then it keeps the ESP8266 on, so that was not going to work. So I moved away from that, and now what it does is it sends a pulse using the 10 microfarad capacitor to basically pulse the Q2 FET on to turn on the voltage regulator. Okay, and that pulse is long enough that Q1 can also read the pulse in, so when the ESP8266 boots up, it can quickly read Q1's value to know that its wake-up source was external. Okay, so I'll go over that in more detail with the schematic. So let's go ahead and trim some of these leads away. Boy, that is not pretty. And we'll just put that to, and just kind of clean up that as much as I can. And we'll go ahead here. All right, well, that's all the rework really we have. So that's the fully assembled board. So now we can go and test it out.